Hey there, Internet Explorers. Ever wondered how websites magically appear on your screen? It's not magic, it's HTTP. HTTP stands for HyperText Transfer Protocol. Sounds complicated? Don't worry, it's just a fancy way of saying it's a set of rules for computers to talk to each other and share information on the web. Imagine you're ordering pizza. You call the pizzeria, place your order, and they deliver it to you. HTTP works similarly. Your web browser, like Chrome or Firefox, is like your phone, the website is like the pizzeria, and the information you request, like a web page, is your delicious pizza. HTTP is the language they use to communicate. It ensures the information is sent and received correctly, just like making sure your pizza order is accurate. HTTP's main job is to handle communication between your browser and web servers. It acts as a bridge, ensuring that the data you request and receive is transferred smoothly and efficiently. When you type a website address into your browser and hit enter, you're initiating a process that involves multiple steps. You're sending an HTTP request to the server where that website lives. This request is like a digital knock on the server's door, asking for the information you want. The server then processes your request and sends back an HTTP response. This response is essentially the server's way of saying, here's the information you asked for. This response usually contains the website's files, like HTML, CSS, and JavaScript, which are the building blocks of web pages. Your browser then uses these files to display the web page on your screen, making it possible for you to interact with the site. Think of it like sending a letter. The process is quite similar in many ways. You write down the address, which is the website URL, ensuring it's correct so it reaches the right destination. You put your message inside the request and send it off. The postal service, in this case HTTP, ensures it gets delivered. The recipient, the web server, reads your message and sends back a reply, the response to your address. This reply contains the information you requested. HTTP ensures this whole process happens seamlessly, managing the data transfer so you don't have to worry about the complexities. This way, you can browse the web without worrying about the technical details, enjoying a smooth and user-friendly experience. HTTP uses different methods to indicate the type of action you want to perform. Think of these methods as verbs in a sentence, each telling the server what to do. The most common methods are get, like asking politely for information. Get me that cat video, please. Post. This is how we send data to the server, often filling out forms. Put, a bit like replace. If you had permission, put would update an entire file on the server. Delete, you guessed it, this is for requesting the removal of data. Each method has its own purpose, just like different tools in a toolbox. Section 4. Deconstructing the conversation HTTP requests and responses. Both HTTP requests and responses have a specific structure, kind of like a well-organized letter. Requests usually contain several key components that make communication between the client and server possible. 1. The method, such as get or post. These methods define the action you want to perform. 2. The path to the resource on the server, for example, /images/cutekitten.jpg. This path tells the server where to find the resource. 3. Headers, which provide extra information about the request, like your browser type. Headers can also include other details like content type and authorization tokens, and sometimes a body which contains data you're sending, like form submissions. This is often used in post requests to send data to the server. Responses also have a structure that mirrors the requests. 1. A status code indicating if the request was successful, like the famous 404 not found. Status codes help you understand the result of your request. 2. Headers providing information about the response, like the file type. These headers can also include caching information and cookies. And often, a body, which contains the actual data you requested, like the web page content. This is where the main content of the response is delivered. Understanding this structure helps you troubleshoot web issues and see what's happening behind the scenes. It allows developers to debug and optimize web interactions effectively. Section 5. HTTP in action real-world examples. Let's see HTTP in action with some real-world examples. First, loading a web page. This is something we all do multiple times a day without even thinking about it. When you type www.example.com in your browser, it sends a GET request to the server hosting that website. This request travels across the internet, reaching the server in a matter of milliseconds. The server responds with the website's HTML file, which your browser displays. This process happens so quickly that it feels almost instantaneous. Second, submitting a form. When you fill out a contact form and hit submit, your browser sends a post request to the server, including the form data in the request body. This data is then processed by the server. The server processes this data, perhaps sending you a confirmation email or storing the information in a database. Third, downloading a file. Clicking a download link often triggers a GET request for that specific file. This is a common action when you need to download software, documents, or media files. The server responds with the file data and your browser starts the download. You can see the progress in real time as the file is being transferred to your device. These are just a few examples of how HTTP works behind the scenes every time you use the internet. Pretty cool, right? The next time you browse, submit a form, or download a file, you'll know exactly what's happening in the background.